the angle between the two planes. Given two planes named as S1, R1 dot N1 equals P1, S2, plane S2, R2 dot N2 equals P2. If S1 and S2 intersect, then the angle between the two planes is given by theta equals at cos N1 dot N2 over modulus N1 modulus N2. Okay, this is the formula. This formula comes from A dot B equals modulus A modulus B cos theta. Take cos theta as a subject and find theta. Okay, theta is an acute angle. Example 4. Find the angle between the two planes. Given two planes S1, S2. To find the angle between two planes, okay, this is the plane S1 and this is plane S2. Okay, we want to find angle between the two planes. So in S1, you have N1. N1 is a vector, normal vector, which is perpendicular to S1. In that, for S2, plane S2, we have N2. N2 is normal for normal to S2. Okay, so we need to find angle between N1 and N2. Okay, this is Cartesian equation form. Okay, from this one, we can say that N1 is equal to 3I minus 2J plus K. And N2 is equal to 3I plus 3J minus K. So, substitute in the formula. The formula is theta equals arc cos N1 dot N2 over modulus N1 modulus N2. So, here you need to find N1 dot N2 modulus N1 modulus N2. Okay, N1 dot N2. Okay, so in the matrix form, 3, negative 2, 1 dot 3, 3, negative 1 and then 9 minus 6 minus 1 is equal to 2. Okay, and then modulus N1. Okay, modulus N1. 9 plus 4 plus 1 is equal to 14. Modulus N2. 9 plus 9 plus 1 is equal to 19. Then substitute all the infos. Substitute. Theta is the angle between S1 and S2. At cos 2 over 14 times 19. And then use a calculator. And the answer is 82.96 degree. Okay, this is acute angle done for this example. Angle between a line and a plane. Okay, this is plane. The blue, this is a plane, consider plane. And for plane P consists of N. N is normal vector which is perpendicular to the plane. And line L, the yellow line L. L consists of V. V is a direction vector for L. Okay, so to find angle between line and plane, okay, this is angle between line and plane. First, we need to find angle between N and V. N and V. Okay, so that this is alpha. Okay. So total or normal is 90. So to find theta, all 90 degree minus alpha. Alpha is angle between and vector N and vector V, direction vector. This is alpha. Okay, and this is theta. This is N. And N is 90. So the answer suppose in acute angle. From the diagram, when the line L and the plane P intersect, A is the angle between line and the plane. Okay, to find A, you need to find B, cos B. Cos B is vector N dot V over modulus N modulus V. And B, we can find B from the using the formula. N is a normal vector to the plane. V parallel to the line. So between plane and line. Okay. Angle A, name as A, is equal to 90 degree minus B. Same like the diagram before this. Okay, this is N, plane, 90 degree, and this is L, V, V or L. So this is angle B. We're going to find angle A. Okay, instead find angle B using this formula. Then to find A, instead 90 minus B. Okay. Example 5. Example 5, given the line, okay, and the plane, okay, intersect at point P. Find the position vector of point P. B, find angle between line and plane. If you want to find point of intersection, okay, between the two lines or one line and curve, we need to substitute one to another one. Okay, here is, you can see R, line, okay, here has R. Here also R. So you can substitute R, this R, using all the values to this R. Okay, because of R, K consists of component I, J, K. This one also R. Substitute in this R. Okay. From the given line, R equals to I plus 3J minus K plus Ti minus J negative 2K. So component I, collect all the like term, component I. So they get 2 plus Ti. Component J, 3 minus Tj. Component K, negative 1 minus 2Tk. Okay, and then here are also, you get I, component J, component K. Substitute. Okay, and then you substitute all. Okay, or change to matrix form. Okay, component I is 2 plus T. Component J is 3 minus T. Component K is negative 1 minus 2T. Dot product. Okay, dot I 1, 1, negative 1 is equal to 4. Okay, using the dot product, component I, 2 plus T times 1, 2 plus T. Okay, 3 minus T times 1 plus 3 minus T. Negative 1 minus 2T times negative 1. So that you get plus 1 plus 2T is equal to 4. Now we're going to find value for T. Okay, can say 2T is equal to 2T plus 6 is equal to 4. 2T is equal to negative 2. Therefore, t is equal to -1. Okay, and at point P, substitute this value to t. This r. Okay, r is equal to 2 minus 1 I plus 3 minus -1, so plus 1 j plus -1 minus -1, so plus 2 k. R is equal to I plus 4j plus k. Okay, this is actually R actually point refer to OP. Okay, therefore P is equal to 1, 4, 1. Because of the question asks you to find point P. This is point coordinate P. This is in vector, position vector. So you need to show in coordinate. Okay, therefore P is equal to 1, 4, -1. Settle for this part. Okay, to find angle between line and plane. Okay, line and plane is plane. A plane consists of n and perpendicular. So line is this is line KL and V because of V is parallel to line L, right? Okay, so this is V. We need to find this angle. Say named as alpha. Our aim is to find line and plane. We want to find theta. Okay, this is theta. So we need to find alpha. So the formula is cos alpha or the formula is alpha is equal to cos n dot V over modulus n modulus V. Okay, means that we need to find vector n, vector V. From L, vector V is equal to this one. This is direction vector. I minus j minus 2k. And vector n is equal to this one. Okay, for plane. I plus j minus k. So we find dot product n dot V. Is a matrix form 1, 1, 1 dot 1, -2. Okay, 1 times 1, 1 minus 1 plus 2. Answer is 2. Okay. Next, we need to find modulus n. Find modulus n. So 1 squared 1 plus 1 plus 1 is equal to 3. And find modulus V. Okay, 1 squared 1 plus 1 plus 4 is equal to 6. Okay, then substitute in this formula. Alpha is equal to cos 2 over 3 times 6. You can use calculator. Let us give answer. 61.787 degree. Therefore, theta angle between line and plane is 90 degree minus 61.87 degree is equal to 28.13 degree. Settle. Okay. Example 6. Find parametric equations for the line L passing through the points A and B. Parametric equation for line. Okay, so vector equation for line, the formula is R equals A plus dV. Okay, this is vector equation for plane. This is vector equation for line. Okay. And then you need to find vector A is line. A is fixed point, lies on that line. Means that you have 2 points. You can take A or B. Okay. And then vector V. V is parallel to line L. So here V is not given. But point A and B lie on the line. You can see that vector V is parallel to vector AB. Okay, and we can say that V is equal to vector AB. So, find vector AB. Okay, substitute here V. And for A, you can take coordinate A or coordinate B. Change to position vector. And done. Okay, this is for part A. Okay, for part B, where does the line intersect XY plane? XY plane, okay, XY plane means that Z, plane Z is equal to 0. Component K, 0. Okay, the K is assumed means that Z is equal to 0. Then substitute in the equation. Okay, later we try discuss part A. Okay, this is point AB, point AB. Okay, this is L, lie. Okay, A, B, lie on L. Okay, and then the formula is R equals A plus T V. Okay, this is vector V. Okay, give direction to L. Okay, here is V not given, but we know that V is also parallel to vector AB. V, vector AB parallel to vector AB, or we can say that V is equal to vector AB. So, find vector AB first, or change vector coordinate A to position vector. 2i plus 4j minus k. Or B, vector B, 5i plus 7k. So that A, vector AB or BA, up to you. Okay, vector B means that B minus A. B, vector B minus vector A. Okay, or you can leave, change to matrix form. 5, 0, 7 minus 2, 4, negative 1. So answer is 3i minus 4j plus 8k. Okay, final answer should be in this form vector. Okay, and this is V. Substitute. Substitute. Okay, substitute. R is equal to A. A you can take coordinate A or B, position vector A or B. Say that I take A, 2i plus 4j minus k plus T V. V is equal to AB. Or you can write down plus T A vector AB. Okay, vector AB is equal to 3i minus 4j plus 8k. Okay, this is vector equation of a line. But we want to find parametric equation. Parametric equation means that you need to give answer x equals something, y equals something, z equals something. So R is equal to, okay, R equal to x, y, z. Or maybe you can change to matrix form. Okay, 2, 4, negative 1 plus T, 3, negative 4, 8. Okay, 2 plus 3T for component I. Component J, 4 minus 4T. Component K, negative 1 plus 8T. So we can say that in parametric form, x is equal to 2 plus 3t y is equal to 4 minus 4t, z is equal to 1 plus 8t. Okay, done for this part. XY plane means that z is equal to 0. From part A, we get this one parametric equation for a line. So z is equal to 0. Z is equal to 0. Substitute 0 equals -1 plus 8t. 8t equals 1. Therefore, t is equal to 1 over 8. Then substitute value t to here and here to get x and y. X is equal to 2 plus 3, 1 over 8. And is equal to 19 over 8. Substitute y, 4 minus 4 times 1 over 8 is equal to 7 over 2. Okay, therefore, okay, z is equal to 0. Okay? Z is equal to 0. Therefore, point of intersect between line and xy plane is 19 over 8, 7 over 2, and 0. Done.